Good day, viewers all over the world. Today, we want to look at the solution of second order linear differential equations with constant coefficients. From the general introduction, you realize that what we have here is 1, here is 2, then here is -3. These are constant coefficients. But let's say we have something like 2s here, that will be variable coefficients. You understand? So the coefficient here is constant coefficient. So this same thing as saying y prime prime plus 2y prime minus 3y is equal to 0. We can write it in this form. So if you want to solve second order linear differential equation, either homogeneous or non-homogeneous, the first step is that we go ahead and look for the characteristics equation or auxiliary equation. That is, in this case now, the characteristics equation or auxiliary equation will be, instead of y prime prime, we change it to m squared. We want to change this equation to an algebraic equation, plus 2m. When we have y prime, we use m. Then minus, when we have y, we are going to use a constant. That will be 3. That will be m raised to power 0. Y will represent m raised to power 0, which is equal to 0. So we have started to change these differential equations to quadratic equation. By the time we transform it to the characteristics equation, and that is what we are going to have. That's characteristic equation. So we are going to solve this quadratic equation. Of course, we can factorize this. So this will be m squared plus 3m minus m minus 3 equal to 0. We factorize this. So m is common. We have m into bracket m plus 2. Then minus 1 is common here. M minus 3 plus 3. The minus 1 is common. We have m plus 3 equal to 0. So we have m minus 1, m plus 3 equals 0. Okay, so m minus 1 equals 0 or m plus 3 equals 0. So what can we say about the equation? This simply means that m is equal to 1 or m is equal to minus 3. So m is equal to 1 or minus 3. So we have gotten the value of m. That is, if you want to solve first order linear differential equation, second order linear differential equations, you transform the equation from differential equation to what is called the characteristics equation or auxiliary equation, which is algebraic in nature. Then most of the time, it usually gives us a quadratic equation. If we have y2, then if this the nth order, we can get something like trinomial equations, depending on the nature of the question. So once we transform the differential equations to characteristic equation or auxiliary equation, which is quadratic in this nature, when we have second order, it's automatically to be quadratic. We solve for the value of m. Then once now we have got the value of m to be 1 or 3. So what will now be the solution to this differential equation? The solution, just say the solution is the first one. Just say this is type 1. Y is equal to, let's say c1, or we can say c1 exponential mx. m1 here is m1 is 1, so we say m1x plus c2 exponential minus 3x. This is the solution. So this example is under type 1. It's under type 1 solution of second order differential linear homogeneous equation. That is that. So let's take another example. We go ahead and take another example, maybe on type 2. Let's take another example. So we take another example. We say example 2. Example 2. The question says solve. What do we want to solve here? Example 2. We have to solve y prime prime minus 8y prime plus 16y equal to 0. Well, this is example type 2. Under type 2. Type 2 simply means simply means that the value of m will be equal when we have real and equal roots. Type 1, when you have real and distinct roots. That is the example of type 1. The type 2 simply means that you have equal and distinct roots. So this same thing as the square y all over the x squared minus 8 the y the x plus 16y equal to 0. We have to solve this. Of course, the first thing is that to generate the characteristics equation. In this case, we have it to be m squared minus 8m plus 16, because this will be y will be m naught. M naught, anything raised by 0 is 1. So that's what we are going to have. That is what we are going to have. So we go ahead and solve for the characteristics equation. So if you do that, the two factors here will be minus 4 minus 4. So we have m squared minus 4m minus 4m plus 16 equals 0. Then what is common here is m. We have m minus 4. Then what is common here is minus 4. We have m minus 4 equals 0. This simply means that m minus 4 equals 0. It shows that m minus 4 equals 0 or m minus 4 equals 0. Okay? M is equal to 4 or m is equal to 4. So in this case now, m is equal to 4 twice. The implication here is that m1 is equal to m2 and is equal to 4. So how do we write the solution under type 2 when we have m1 and m2, the two roots to be equal? If we have the two roots to be equal, then the solution is, we say y is equal to c1. I'm using c1. C1 is just arbitrary constant, and c2. You can say to use maybe a. Okay, let me use a. You can say a exponential 4x plus the second one will now be x. The second one will now be maybe b x exponential 4x. That's what the law says. That is the same thing as what is common. We can bring out what is common. We can have a plus bs into bracket e exponential 4x. This will be the general, this will be the solution to these differential equations. So this will be the solution to these differential equations. So under type 2 differential equations, what we do there is that the type 2 differential equations, they normally have the same value, the same root. Then this is how we write the solution. Then let's take one example under type 3, where we are going to have complex solution. So what do we get there? When we are, if you have to, let's take one example under type 3. So under type 3 differential equations, they are going to have, under type 3, they are going to have complex solution. That is where we have solve the square y all over dx squared, okay, plus 4 dy dx plus 9y equals 0. So this is example under type 3. Under type 3, if you resolve this, if you find the characteristics equation, at the end of the day, the roots will be complex. So they are going to have imaginary solution. Then there's the way we write the solution. That is what, after this, I'm going to close the class. So this same thing as m2 plus 4m plus 9 equal to 0. So what are the two factors that we can get there? Of course, we cannot factorize this equation. This equation cannot be factorized. It's not factorizable. We can't factorize this. So since we cannot factorize this, I can go ahead and use the quadratic formula. I'll say m is equal to minus, this is a. Here, a is equal to 1, b is equal to 4, and c is equal to 9. So I will say m is equal to minus b minus 4 plus or minus square root of 4 squared minus 4ac. That will be 4 times 1 times 9 all over 2a, 2 times 1. So here I'm going to have minus 4 plus or minus. If you look at the numerator, what are we going to have? This will be 16 minus 36 all over 2. So here I'm going to have minus 4 plus or minus square root of minus 20 all over 2. That is what I'm going to get there. That is what I'm going to get there. That's what we are going to get there. If you look at this critically, that is what we are going to get. So here, what do we do? I can still change this to minus 4 plus or minus, here, minus 20. Minus 20 is we can't find the square root of minus 20. The only thing we can do there is that we know we can change minus 20. The square root of minus 20 can be the same thing as square root of 20 times minus 1. This is same thing as square root of 20 times square root of minus 1. Then here will be square root of 20, will be square root of 20, will be 2 root 5. 2 root 5 times square root of minus 1 is I. So this same thing as 2 root 5I. So we can never get this solution in the real sense. We can only change it to the complex sense. So this will be square root of, instead of square root of minus 20 now, from what we have done here, replace 20 as 2 square root of 5. Okay? That will be 2 square root of 5. That's what we are going to get. That's what we are going to get there. 2 square root of 5I all over 2. Okay? So that from there, 2 can divide through. So m will be equal to minus 2 plus or minus square root of 5I. So m is equal to minus 2 plus 5I x. Minus 2 plus square root of 5I, or minus 2 minus square root of 5I. That will be the value of I. So we realize that in this case, the value of I is imaginary. It's imaginary. Okay? So when we have imaginary solution, how do we write the solution? Of course, we can say that the solution is y is equal to, we can use C1 or any constant. C1 exponential minus 2 plus square root of 5I x plus C2 exponential minus 2 minus square root of 5I x. So this is the solution. But this solution can be, we can rewrite the solution. Of course, we can write the solution as, say, y is equal to a exponential, this 2x can come out, minus 2x, okay, cos square root of 5 plus b exponential minus 2x sine square root of 5x. Please check the video. So here, the final solution can be e raised to power minus 2x can come out. So that we have into brackets a cos square root of 5 plus b sine square root of 5. That will be the final solution. So we have been able to consider the three types, all the three types of second order linear homogeneous differential equations. You know, in case of homogeneous, the right hand side is 0. So we only talk about complementary solution. We only talk about this solution. But once we go to non-homogeneous, where the right hand side is not equal to 0, we are going to look for two solutions. That will be complementary solution plus particular integral. But when it is homogeneous, we only find one solution, which is complementary solution. Is going to represent the general solution. Then under second order linear homogeneous differential equations, there are three types. The first one is when the characteristic equation, where the value of characteristic equation are distinct and real. That's type 1, the first example. The second one is type 2, where the roots of the characteristic equation are distinct and they are the same. That's the second example. Then this third one is where the roots of the characteristic equation are not real, but they are complex. When we have complex simply means that we cannot get this solution in the real sense. We can only get a solution in the complex sense. Then this is how we write that. So we have been able to consider all the three types in this video. Thank you.